Hello students, welcome to mathematics class. Students, this is part 17 of the chapter number system. In this part 17, we will go for learning or recollecting identities related to square roots. Later we will go for rationalizing the denominator. Consider 1 by root 2. Considering this, can you tell where it shows up on the number line? Which means, can you tell where will it be there on the number line? Let's say I have got a number line marked on it with 0, 1, 2, where between 0 and 1 I have marked 3 points which are equal apart. That means I have divided 0 and 1 into 4 equal parts. Similarly, 1 and 2 is divided into 4 equal parts, and so on. Now, can you show it up where this 1 by root 2 will be on this number line? You know that this 1 by root 2 is an irrational number. But how to represent this irrational number? You know how to represent root 2 but not 1 by root 2. Knowing the value of root 2 from the square roots chapter of class 8th, it is 1.414, so on. How to divide 1 by that non-terminating, non-recurring decimal number? It is a bit difficult to show it up, right? Now let me give you a hint. Maybe it is easier to handle if the denominator is rational. How to make the denominator rational number? Let us see if we can rationalize the denominator. Remember, we are rationalizing the denominator. To make the denominator into rational number, I may use identities involving square roots. How do we do this? This we will learn after learning identities related to square roots. You have already learnt. In this case, when I multiply both numerator and denominator by root 2, then this 1 into root 2 becomes root 2 by root 2 into root 2 becomes 2. Knowing the value of root 2, if I substitute it here, 414 and so on, correct to 3 decimal places, if I take divided by 2 becomes it is 0.707. Approximately we can say it is, this is 0.5 and this is 0.75. It lies in between them somewhere here. This is how we do understand the need of rationalizing the denominator. Identities related to square roots. If P and Q are two positive real numbers, square root of P into Q can be written as separately root p into root q. Second identity, root under p by q can be separately written as root p upon root q. So, to the numerator we can take separately root, and to the denominator we can take separately the root. Third, root p plus root q into root p minus root q is p minus q. This comes from the identity x plus y into x minus y is x square minus y square, where x and y are root p and root q respectively. So, root p whole square is just nothing but root p into p, which is nothing but root p square. We can write like this, where it gives you for 2 times of p multiplying by itself, 1 p comes out, or else we have root is just nothing but 1 by 2 as a power of that p. Now whole power 2, where p power 1 by 2 into 2, where p equals to 1 by 2 and 2 when they are multiplied gives you 1. So, p power 1 is p. This way also you can understand. Next, another important identity is p plus root q into p minus root q is p square minus q. Similarly, with this same x plus y into x minus y equals to x square minus y square, from this identity only it comes, where x is p and y is root q. Y is root q. Now, the fifth one is root p plus root q multiplied by root r plus root s, where we do it with the distributive property. Root p into root r is root pr, root p into root s is root ps, root q into r is root qr, root q into root s is root qs. Then next identity is root p plus root q whole square. Root p plus root q whole square can be done using same fifth identity, root p plus root q into root p plus root q. Root p into root p is, as I said, root p square. So, root p square gives you p, then root p into root q is 1 time root q, root q into root p is 2nd time root pq. So, their sum gives you 2 times of root pq, where root q into root q gives you root q square, where q will come, or else we can use the other identity x plus y whole square is x square plus 2 times xy plus y square. So, from that identity also we can find root p plus root q whole square, where x is root p, y is root q. Then x minus y whole square identity will give you root p minus root q whole square. Root p minus root q whole square is p minus 2 times of root pq plus q. Okay, this will help you a lot, these identities. Then moving on to the solving questions based on these identities. Simplify root 5 plus root 11 into root 5 minus root 11. It is solved using the identity root p plus root q into root p minus root q, where root p, root q, you could clearly see root p is root 5, root q is root 11. So the answer would be here from this 5 minus 11, nothing but minus 6. Let us move on to solving some problems from the exercise. Example number 16. Simplify the following expressions. Here, first one. So 5 plus root 7 multiplied by 2 plus root 5. Just like distributive property, 5 2s are plus into plus is plus, 5 into root 5, root 7 into plus 2, plus root 7 into plus is plus, 2 into root 7 is 2 root 7 or root 7 into 2, both ways we can write. Here it is just product of 2 and root 7. Next, plus root 7 into plus 5 is plus root 7 into root 5. Now in total 5 2 is 10, 5 into root 5 plus 2 into 7, root 7 into root 5 is root under 35 we can write, and this is the answer. Then moving on to the question number 2. Question number 2, it is so simple. 5 plus root 5 into 5 minus root 5, it is same x or p plus root q into p minus root q which gives you p square minus q. This is the identity we have learned. You can use it here. 5 square minus 5, which is nothing but 25 minus 5 is 20 is the answer. Moving on to the question number 3. Root 3 plus root 7 whole square is using the identity root p plus root q whole square, which is p plus 2 times of root pq plus q. So using this identity we will do it. So 3 plus 2 times of 3 into 7 plus 7, where 3 plus 7 it gives you sum of 3 and 7 is 10 plus 2 times of 3 7s is 21. So this is the answer. Now moving on to the question number 4. Root 11 minus root 7 into root 11 plus root 7 is again x minus y into x plus y type only. So x square, that means root 11 whole square minus root 7 whole square. Root 11 square is 11 minus root 7 square is 7. So 11 minus 7 is 4. 4 is the answer. Then we'll go on to the next question. Question number 17 or example number 17. Rationalize the denominator. I have already told you how to rationalize the denominator. Here 1 by root 2 we have to rationalize. See children, whenever we wanted to rationalize the denominator, we need to identify by which this root 2 multiplied can give you the rational denominator. You know, when root 2 is multiplied by root 2 gives root 2 into root 2. Root 2 when it is multiplied by root 2 gives root 2 square gives you 2, which is a rational number. So that's why we multiply both the numerator and denominator by this root 2 and convert 1 by root 2 into root 2 upon 2. Here is the rationalizing the denominator root 2 is done. Okay. Now here I would like to bring you one important called rationalizing factor. The word factor. So rationalizing factor or F we say. So what is the rationalizing factor of root 2? Rationalizing factor of root 2 is root 2 itself. Now what is the rationalizing factor of root 5? It is root 5 only. That means whenever root 5 is multiplied by root 5 gives a rational product, that is when root 5 is multiplied by root 5 it gives 5. Okay. Next, what is the rationalizing factor of root a plus root b? So root a plus root b, when it is multiplied by root a minus root b, it gives a minus b, like in the last question we did. See, rationalizing factor of root 11 plus root 7 is root 11 minus root 7. Why? Because when root 11 plus root 7 is multiplied by this rationalizing factor gives you 11 minus 7, that is 4, which is a rational number. So children, rationalizing factor of root 11 plus root 7 is root 11 minus root 7 and vice versa. For this will be the rationalizing factor, for this one, that one will be the rationalizing factor. So how do we say that? For plus, minus is taken as a rationalizing factor, for minus, plus is taken. Understood? Let me write in a proper way so that you do not get confused. Here I will write as a rationalizing factor of root a minus root b is root a plus root b. Okay. So this very important. So rationalizing factor of root x is root x only. Rationalizing factor of root a plus root b is root a minus root b. Rationalizing factor of root a minus root b is root a plus root b. Then moving on with this knowledge, rationalizing the denominator. It means rationalize the denominator means to convert the denominator containing square root term into rational number by finding equivalent fraction of the given fraction. So we found 1 by root 2 equivalent to root 2 by 2. So it's equivalent fraction of this 1 by root 2, but with the denominator rational, for which we can use the identities of the real numbers. For example, rationalize the denominator 7 by 7 minus root 3. So what is the rationalizing factor of 7 minus root 3? It is 7 plus root 3. So the solution will be, we use here identity p plus root q is p minus root q, when they are multiplied p square minus q gives. So with that I will rationalize it 7 upon 7 minus root 3. When I multiply both numerator by 7 plus root 3, and to the denominator also 7 plus root 3. When I multiply, it becomes 7 into 7 plus root 3 upon 7 into 7 is 7 square is 49 minus root 3 into root 3 is root 3 square, it is 3. So denominator is 46 and numerator is 7 into 7 plus root 3. So this is the equivalent fraction of the given 7 by 7 minus root 3, but with the denominator being rational. Let's go for solving example number 18. Rationalize the denominator 1 by 2 plus root 3. First we will find rationalizing factor of 2 plus root 3, which is 2 minus root 3. Okay. Then solution 1 by 2 plus root 3, I am multiplying to both numerator 2 minus root 3 and denominator also by 2 minus root 3. So 1 into 2 minus root 3 gives you 2 minus root 3 only, upon this 2 plus root 3 into 2 minus root 3 is 2 square minus root 3 square is 3. It implies 2 minus root 3 upon 2 square is 4, 4 minus 3. It implies 2 minus root 3 upon 1, where if the denominator is 1, we need not write it specifically. So 2 minus root 3 is the equivalent fraction of 1 by 2 plus root 3. Okay. Then moving on to the next example number 19. Rationalize the denominator 5 by root 3 minus root 5. So here also first we will find rationalizing factor of root 3 minus root 5, where by changing just sign here root 3 plus root 5 we will get rationalizing factor. Now I will multiply both the numerator and the denominator by that rationalizing factor root 3 plus root 5. So in the denominator we will get root 3 square means 3 minus root 5 square means 5. Here always we will get minus. Remember, this is always negative, because a minus b into a plus b always a square minus b square. So we will get the minus 2 as the denominator. Numerator is 5 into root 3 plus root 5, root 3 into root 5, 5 into root 3 plus root 5 is the numerator. Now this can be written as minus 5 by 2 into root 3 plus root 5. Then moving on to the next question. Rationalize the denominator 1 plus 7, 1 by 7 plus 3 into root 2. Now in this question we will find rationalizing factor of the denominator 7 plus 3 times root 2, which is 7 minus 3 times root 2. Just we need to change a plus b format to find its rationalizing factor, a minus b format. That's it. Now we will multiplying the given fraction by the rationalizing factor. We get 1 into 7 minus 3 root 2 upon 7 plus 3 root 2 multiplied by 7 minus 3 root 2. So 1 into 7 minus 3 root 2 gives same one, 7 minus 3 root 2 upon here a plus b into a minus b is a square minus 3 root 2 whole square, where 7 minus 3 root 2 upon 7 square is 49 minus what is this 3 root 2 square? 3 root 2 square can be written as 3 square into root 2 square. 3 square gives 9, root 2 square gives 2. So 9 2s are 18 will be the value which I have to substitute here. That means it is 7 minus 3 root 2 upon, so we got 31 being the denominator, which is rational. So this is how we do rationalizing the denominators for the given irrational denominators. Okay, with this I'll wind up today's session. Take care of yourself. Jai Hind. Thank you.